Part C of the question asks you to draw the elevation and plan of a horizontal line on the surface EFG and project an auxiliary elevation which will show on edge view. So this is very much like the strike and dip of the planes within a geologic geometry question. So we're looking at the plane EFG this time. So in elevation we can draw our level line across the plane. Now using orthographic projection, this point on the line EG can be projected downwards and it will locate it on FG or EG, in the plan. So what we're looking at doing next is we are going to project along this level line to create an auxiliary elevation of the plane EFG. So again, we want to project out a point view of the level line, is what we're going to be bringing out. E and G, and then to set up our new ground line for that, and just for the sake of changing it up, I'm going to just call it X3, Y3, but it's going to be the ground line just because this was X1, Y1 and X2, Y2 already. Where are we going to take the heights from? We're going to take them from elevation again. So E is on the ground, F is this height, F, and then G over here. So the heights in elevation never change. Again, similar to strike and dip, this should end up as one straight line between the 3 points. Okay, if it doesn't, a small inaccuracy there, that may be the cause of it. The second part of that, part C, is indicate the angle of inclination of the plane to the horizontal plane. So again, that's your angle. And again, you can take out your protractor. .54 degrees. 54 degrees. Okay. So that's part C of the question done. Final part then is locate the position of a point P on the plane EFG, which is a distance of 40 millimeters from the horizontal plane and 68 millimeters from the vertical plane, and determine and indicate the true length of FP in this case. So when we take a look at that one, point P is a distance of 40 millimeters from the horizontal plane. So the XY line here is representing your horizontal plane. If you take a measurement of 40 millimeters up, it is on the level line from F. Okay, so point P will be located somewhere along the level line from F. Right. The next part of that instruction, it tells us that it is 68 millimeters away from the vertical plane. So what we can do is we can plot the distance of 68 millimeters from the vertical plane. Again, the XY line in plan is now a vertical plane. So I've measured 68 millimeters down. I'm going to strike a line across, and where the 68 millimeters from the XY line or the vertical plane is, take a horizontal line across. Where it intersects with our level line from F is going to be point P. Again, we can project that back up into elevation. And that's point P here. Final part of that was indicate the true length of FP. So, if that's a level line, we don't know if that is perpendicular to us at the moment. Okay, so when you look in plan at a level line, you will always see the true length of it. So we can actually take it from point F over to point P here. Okay. That is our measurement that we're looking for here. So that looks to be approximately 46 millimeters. And that's that question complete.